Alrighty, welcome back, boys and girls. It's your math man, Mr. Shank, coming to you live from Walker Grant Middle School. And in this video, we're still cruising through that Math 7 SOL review, and we're working on that 7.12. So now talking about some equations. So make sure you can do some 1 and 2 step equations and be able to also see how the models work. So now for number 1, it says this. It says which algebraic expression best represents a verbal expression below. So it says 11 times the sum of a number and 5. And so since it's talking about the entire sum, it's going to use those parentheses. And so it says 11 times a number and 5. And then it says for number 2, it says Marjorie bought 24 bottles of juice. Each day she opens and drinks 2 of these bottles of juice. Which of the following best represents the number of unopened bottles of juice Marjorie has at the end of the day? So she's taking 2 out per day. She started with 24. She's taking 2 out per day. So it would be D for that one. Then in number 3, it says which of the following is the algebraic form for the verbal statement below. It says 13 less than, so that's that transition word, so it's going to go before, so a minus. The product of a number, product of 4 and a number, n is 5. So we're going to have 4n minus 13 equals 5. 4n, there it is. Again, notice the differences between this number 3 and this number 1. Again, using those parentheses, it has the product is just those 2 together. And it says for number 4, it says select each of the following that is an expression. Again, that is no equals sign, symbol, say symbol. So is this an expression? Yep. Is this an expression? Sure. Is this an expression? Absolutely. It is not. This is not. Again, if it has an equal sign, it is an expression. Excuse me, if it has an equal sign, it is an equation. There we go. So equation has the equals symbol. Okay. Moving on. It says for number 5, it says find the value of x in the following equations. All right. So we're just solving for these equations, and then we could say use Desmos to check. The way it works is like this. So let me see. Make sure it's still on there. All right. So for the first one, it has. And let me actually pull out some scratch paper, that way it's not too close together. All right, so for let's do number 5A. Number 5A, we have x plus 4 over 3 equals 19. Always use your inverse operations, and so what I can do is this. I can say, well, if I need to get rid of this 3, and so I can multiply both sides by 3. And so I have x plus 4 is equal to, let's do 19 times 3. 57, sounds good. One-step equation, get x by itself, subtract 4 to both sides, so we have x equals 53. Again, you can check using that back substitution, or if you type it in exactly as it looks in your original equation, it should work out. So what I can say is this: I can type in my left side. I have x plus 4. I have this all divided by 3. And we're saying, okay, if these 2 numbers on the left and on the right, if these 2 numbers are the same, then we have an equation. When x equals 53, are these 2 numbers the same? Is 19 equal to 19? You better believe it. So we are good. Again, make sure you can use that Desmos calculator. All right, So now for number 5b, we have 8.3 is equal to 14.5 plus 5x. Trying to get x by itself, let's use those inverse operations. So I can subtract 14.5 from both sides. This cancels out, the 5x comes out, so I have positive 5x. And then let's use that Desmos calculator to make sure we get those values correct. So we have 8.3 minus 14.5, and so this is going to be negative 6.2 is equal to 5x. Divide both sides by 5. So I have to take that answer, divide by 5. And so we're going to say negative 1.24 is equal to x. Even though it looks like a kind of a rough answer, what we can do is plug it back in. So let's say, all right, if we have 14.5 plus 14.5 plus 5x, when x equals negative 1.24, let's make sure it's a negative. And yes, indeed, again, since that's our equation that we originally had, we know this is true. All right, and then for number 5c, we have this equation. we have 7 minus k over 5 is equal to 22. Again, equations, people will try to get caught up on it as being difficult. It might look difficult, but I can assure you it's super simple. You can always double check to make sure your answer is correct. If it gives you 4, or if it's a multiple choice answer, you know one of them has to be correct, so what you could do is even plug them in and try it out to see if it works. However, you can always use your inverse operations. You can think of it just like unwrapping a present. So you're trying to undo what has already been done. So I'm trying to get that k by itself, so I can subtract 7 from both sides. So I have negative k divided by 5 is equal to, let's have 15. Make sure you always divide by the coefficient. So the coefficient's 1/5, or excuse me, negative 1/5, so I can do the same thing as multiplying by 5 to negative 5 to both sides. So times negative 5. This is going to be k is equal to, what was that, 75? So you had negative 75. Let's see if this is correct. So we had 7 minus k over 5 when k is equal to negative 75. Boom, we get 22, which is what we had originally. Excellent. All right. Make sure it's all in there. It is, and so we're good. All right. Keep that to the side. That was on page 28 in case we need it. All right. So now it has, for number 6, it says which property justifies the work between step 2 and step 3. So we're talking about these 2 steps here. So we're saying, okay, let's kind of notice what is similar, what's different. Well, okay, that right side of that equation is all the same. However, what is different? Well, we have 1/3 here times 3, and now we just have 1. So what would be that property? Well, I know that I'm talking about an inverse. Since I am resulting in 1, it's going to be inverse property of multiplication. Moving on, for number 7, it has this. It says Maria called her sister long distance on Wednesday. The first 5 minutes cost $3, and each minute after that cost 25 cents. How much did it cost if they talked for 15 minutes? So let's try this. So the first 5 minutes, so let's say each minute after that, so we're going to say first five is $3, so initially we'll say it's $3, and then it's going to be 0.25 times x, and we're going to say we're going to let x equal 10. And the reason why I'm doing that is because we already counted for that 5 minutes. So if we let x equal 10, this will just be as follows. So we do 0.25 times x plus 3, and we can do x equals 10. And so it's going to be $5.50. All right. And for number 8, it says use the model to answer the question. Make sure you can do these. These are super simple. Again, use those pictures, be able to count out and say out loud what you're doing. Okay, so it says which equation and solution is represented by the model. So again, use that key or legend that you are given. And so it says this, how many on the left side of my equal sign, how many x's do I have? I have 2, so I'd say 2x. And then how many of these do I have? I have 3 -1, so I'd say -3. Already halfway done. Then I can count up on the right side, what do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 positive ones. Simple two-step equation. Let's eliminate some answers that we have. So this one is false and that one's false. Let me do this on the side here, if it will let me. So let me actually do, so this is number 8. I had 2x minus 3 equals 9. Two-step equation, get the x by itself. Inverse operations, I have 2x equals 12. Always divide by the coefficient. So I have x equals 6. Let's check to make sure it works. So we have 2x minus 3. If x equals 6, our equation already equals 9, so this is true. So for this one, we would say it's going to be A. It's going to be A for that one.